Hey everybody, welcome back. So Monte here, and we're talking about SPV Math, Bridge to College, Math 107. Alright, so we had spring break, we came back, took a week off, getting situated, and next week, week 30, April 26th, let's get back in the swing of things and make sure that we do some math. Okay. So remember, these videos, you can find them in our team's channel, Bridge to College Math, and they're posted here, but you can also, at any time you want an old one, just go to the stream channel and click on it. Alright, so let's get started. So the first thing we need to do is find the internet, find Spokane Public Schools and our digital tools, and then we want to find Clever. Then we want to find Blackboard. Once we find Blackboard, we want to find our class. So, if you're a Math 107 student, right here, remember it tells you that none of the work exists here. You have to go to Bridge to College. Okay? At the same time, the video is posted. Each week on the announcement page, I post the old videos, so you can find them all there. Okay, so let's go to Bridge to College Math. Alright, so we had a catch-up week this past week, and now we're getting back in the swing of things. Coursework. It's up to you. You pick the assignments you do each week. So the first couple of weeks we focused on linear systems, where X marks the spot, trying to graph different lines and different constraints. Last week I pushed you into exponential functions and logarithms. And then the next couple of weeks we'll do quadratics, and the next couple of weeks we'll do some stats, alright? So for this week, exponent functions, last video we focused on lesson 1. I'm going to go down to compound interest because money, that's where it's at, right? And let's see, going on a cruise, scavenger for college. Ooh, college. Let's click on college. Boom. Alright. Now, let's just start these problems so that we are all in the same boat. If you remember the last time we were together, I made a comment about having a cheat sheet. Okay, so we'll go to announcements here, and I can repost this, but we need a cheat sheet for exponents. Okay, so I'll put that in this week's announcements, and that cheat sheet's going to look like this: growth and decay. Alright, so these are the basic formulas to do these problems. Okay, you invest money in a bank account. The same terminology and notation applies. Newborn baby invests money today in order to pay for the child's college 18 years from now. $10,000 of savings they wish to deposit all at once and withdraw 18 years from now. Okay, so we have an annual percentage rate of 6% monthly, annual percentage rate of 6% flat. Then, what do we have to put in if we want $150,000 18 years from now? Okay, how much would you need to deposit? Okay, so on this one, we're going to assume the 6%. Let's do 6% on all three. Okay? Alright. So I've already copy-pasted the actual formula in here for us to get started. Okay? And what are we talking? 18 years, $10,000, 6%. Alright? So here we go. So in the first one, we have $10,000, okay, and the rate, let's redo that, R, little r, is the rate, and that's going to be 6%, but we don't have percent buttons on our calculator, so we got to remember that it's 6 divided by 100, which is 0.06, alright? So 0.06, and we have a time frame of 18 years. And then in this one, monthly. just like a credit card, every month. Rent every month. So that's going to be an n value of 12. Now the first thing you're going to say is, I'm not seeing the letter n in this formula. Okay, so I might have to make sure, here it is, future value, right? We want money in the future. So n is right here, compound periods per year. So the 1 per year, that's 1. Monthly, that's 12. So I'm going to put an n and an n. Okay, so we're going to say the final value of money is the start value of money, and these are all growth. So 1r over n nt. All right, so in problem A, compound monthly, how much would we have? So A, the final value of money is going to be $10,000. 1 plus R, 0.06, monthly, divide by 12, 12 for 18 years, right? 12 months, 18, that's how many payment periods there's going to be, okay? So if we do that math on a calculator, you'll get an answer. I'm going to help start this because I've learned over the years there's so many places to make a mistake. So I'm going to start right here. 0.06 divided by 12. And this gives us 1 plus 0.005, 12 to the 18, right? Okay, 10,000. Now 1.005 caret key parenthesis 12 times 18. That's the number of payment periods. And we're going to have $10,000, 2.936 rounded up, times $10,000. Okay, so in A we get $29,367.66. In B, we're only doing it once a year. Okay, it's not monthly. So 1 plus 0.06, 18, because it's just once a year. This is just a standard problem. So we get 10,000, 1.06 to the 18, 1.06 caret key to the 18th power times 10,000, and we're going to get 28,543.39, which this one's bigger, which makes sense because you're not compounding every month. You just compound it once a year. Now C. C, we want to have 150,000. How much do we need to put in? Okay, so now C, we have a final value of 150,000. You know what? I'm going to redo that so it all fits on one page here. C, we want $150,000. Okay, and we're going to assume that 6%. Our start value, 1 plus 0.06 for 18. Okay, 150,000, 1.06 to the 18th power. 1.06 to the 18th power is 2.85. 2.8543. Let's divide both sides by 2.8543. divide by 2.8543. So let's take 150,000 divided by that number right there, 52,000. We need to start with $52,551.57. Okay, so there's C, there's B, and there's A, all based on that relationship. So hopefully that was helpful. You pick which problem you want to work on. Next week we're actually going to do a problem using logarithms. And the reason we need a logarithm is to actually calculate the exact t-value. Logarithms is used to calculate t. All right. Have a great week. Reach out if you need me. Bye, everybody. Bridge to College and Math 107.